All right, it's evening now. It's about 9:20 in the evening, and I'm trying to just have another little reading session. So I'm just gonna, instead of drawing or anything, I'm gonna try to verbalize my thoughts. So I want to think for a second about restriction maps. So yeah, it would actually be really beneficial to draw this. God, let's see if I can. Cool. This might work. All right. So a restriction. So imagine I'll probably draw this in a few different formats. Imagine we have the arrow of time. Whoa, that's weird. And maybe, God, let me think about this. The thing is that a behavior type, it's like the sum of all possible temporal intervals, which is why I keep coming back to this thought of, it just reminds me of something supernatural, like this supernatural kind of projection of something into all possible temporal states. Eventually I'll think of a good specific comparison. But so if we think about I don't know. If we think about all possible movies, each of these is just imagine it's a movie. I'm still waiting to get the specifics, but yeah, let me think about this. So if the behavior type is the behavior type of movies, what that actually means is that B that actually means that B is the set of not only the duration of every movie. One second. I don't mean the duration, the time. I mean the content of the movie in its full duration. Okay, now this set not only contains the content of every single movie in existence, even maybe movies in the future that haven't come out yet. Whoops. It also contains every single sub duration or excerpt or clip I'll probably use the word clip. It also contains every clip. And for a second, I want to mention, I'm wondering if we could either do every movie that like actually exists in the history of our universe, or if we can actually go further to be like just every possible movies that no one in the history of the universe will make, but which are certainly possible. So it has every possible clip from every movie. And this just immediately reminds me of the power set in set theory, because we have if we have like, let me think about this. I mean, if we think of an image as, like a actually I need to think of this. Like, I'll assume that there's so we have like an image is like a bounded region in R2, I believe. And time, I usually think of time as like isomorphic or whatever to the real numbers or the continuum. And so one second. Like, just to make this simpler, we're going to assume that the size of a picture is going to be like bounded or something. Okay, I need to remember where I was even going with this. Okay, I think the idea was like to actually find an expression for like, God, I can't believe it. I'm like, my mind is like stalling right now. I'm just gonna carry on for a second. Okay, so let's just say that's our set. Is every I want us to talk about power sets. Okay. So the power set. Okay, I'm going to take a little detour now, but it's always good to take a detour if it helps you think more about stuff. The power set is the set of all subsets. And in like formal logic, when you define set theory, you have like, you generally have one relation, which is the set membership relation. One second. So, first of all, let's define the subset operation, and I don't have math type in here, so let's say the subset operation Sorry, actually it's a relation. The subset relation is the subset relation relates to sets it is defined as, I don't know why I'm choosing such a weird phrasing, that every element in one set is in the other. And it's really cool to forget the meaning of the like set membership symbol, and just think about what would this property be if it was just any relation, like abstractly. We don't know what the relation symbol is. Like, well, oh man, that is so weird. I don't know if I just got confused, as I often do when I think about logic. But anyway, think about this. Relation symbols. Okay, so relation symbols. Yeah, that's another confusing thing. As I'm wondering, like, well, anyway. So if we just think of any arbitrary relation, the subset relation actually is of this form. A relate B implies A relates C, I believe. So let's say that B and C are two sets, and we're saying if A is in B, then A is in C, and this is for all. And I also want to explore something that I've been thinking about, where when you define a symbol, you actually state it as a statement of equality. So I would like to say that B, and we have a new relation which we'll call T. BTC equals. And so, yeah, because they both ultimately evaluate to true or false. So I'm saying with this equality that in any time you see BTC, you can substitute it with the expression for all A. ARB implies, whatever, I'll just do it like this. ARC. So, yeah, so taking away the metaphor of membership and just thinking about this abstractly and symbolically. I'd love to think about that more. But I'd also love to think about variations on this, like for all A, ARB implies wait, just think about this for a second. Okay, yeah, I know that there's a lot more to think about, because usually the equality symbol is only applied to terms, not to formula. So I don't even know if it's possible to write something like this in first order logic. Okay, now I understand what I did wrong. You don't do it with equality, you do it with a if-then statement.